This is the syllabus tour for Organic Chemistry 2 for the spring 2022 semester. So the class takes place in Walker Science Building, room 137, Monday, Wednesday, Friday from 11 a.m. to noon. My office hours this semester will actually be in the Walker Science Tutorial Center, which is room 238. Tuesdays from 8:30 to 9:30 a.m. and Thursdays from 9 to 10 a.m. So my physical office is on the Hattiesburg campus in the Tech Building, room 429. So you can reach me at the email address as shown. Expect a reply within about 8 hours. If you don't get a reply, just send me a reminder and I'll follow up with you. My office phone is listed here. So if you need to call me, leave a voicemail. It'll convert that voicemail to an MP4 and it will send that to my email, which I'll then read. My YouTube channel, which this video is posted on, and other screencasts as well, is shown here. So let's get into the meat of the syllabus here. So I'd like you to pay particular attention to the student learning outcomes. So as you see for the entire course, upon completion of the course, you should be able to do these 5 SLOs, and the action verbs highlighted in green are things that you need to be able to do. So number 1, propose retrosynthetic strategies that utilize natural bond polarity disconnections. So in terms of learning the reactions, you sort of learn the reaction in the forward sense. We're going to spend time looking at functional groups and products and sort of reverse engineering that back to the starting materials. Number 2, devise synthesis routes that utilize well-known reactions for the synthesis of small organic molecules. Again, that falls under the guise of retrosynthesis. Number 3, utilize more complex functional group transformations in organic synthesis, including reactions involving alcohols, amines, aldehydes, ketones, and carboxylic acids. And so that order follows the oxidation state order of the modules that we'll talk about this semester. Number 4, illustrate complex reaction mechanisms through the use of arrow-pushing formalism, Lewis acid-base theory, and molecular orbitals. So you'll want to know how electrons move to form and break bonds, and be very rational about functional group reactivity. And number 5, interpret IR, NMR, and mass spec data to identify signature organic functional groups and elucidate chemical structures. So the course learning materials are found in Canvas. They're already linked through there through the first day program, so you should have access to them. So here is the course delivery. There are 5 modules. Module 0 is the syllabus. Essentially, read the syllabus, take the syllabus quiz in Canvas. There will be a separate Canvas tour video that you can watch. So here are the chapters that we'll go through in each module. The number of class periods per module, the lectures per module. So notice it's essentially 1 less because you're going to have an exam as part of one of those class periods. So we're going to be together for 42 classes, 37 of which are lectures, and then 5 of which are exams. So the types of learning activities that you're going to need to do in this class, number 1 is really the textbook readings. You should spend quite a bit of time reading the chapter materials. You're going to take pre-module quizzes in Canvas on the syllabus so that you understand what you're supposed to be doing in each module. Something new this semester, there's going to be assigned attendance points per lecture using a zip grade form that will be explained during class. Textbook problem sets, these are no longer assigned, so you're strongly encouraged to do as many problems from the course textbook as you feel necessary to learn and understand the material. So rather than me assigning these homeworks problems for points, you can do as many problems as you want or not do any at all. It's sort of up to you this semester. So exams, this is where the majority of your points are going to be assigned. There's going to be 4 module exams, each worth 100 points. So that's 400 points for the module exams. The final exam, which takes place at the end of Module 5, is worth 210 points. And that is a cumulative exam provided by the American Chemical Society that has 70 questions, and I've assigned 3 points per question. So here is the tentative schedule of topics. So we're going to go through Module 1. That's oxidation state 1, oxygen functional groups, alcohols and phenols, ethers, epoxides, and thioethers. That's chapters 11, 12, and 13. You'll have an exam Monday, January 31st on Module 1. Module 2 is oxidation state 2 and 3, oxygen functional groups. That's aldehydes, ketones, and carboxylic acids, as well as carbohydrates. You'll have your Module 2 exam February 25th, that's a Friday. Module 3 is 1 chapter only. That's carbon-carbon bond formation via substitution at the alpha carbon. That's chapter 21. Alpha carbon chemistry, enols and enolates. And the reason that's its own module is because there are a lot of reactions within that module. That exam is on Wednesday, March 23rd. Module 4 is now oxidation state 1, 2, and 3 functional groups with nitrogen. That includes amines, peptides, and proteins. So that's 2 chapters, 22 and 25. That exam is on Monday, April 18th. And then we're going to round out the semester with Module 5, conjugation and aromatic chemistry on these 3 chapters, 16, 17, and 18. So that's the last module because it's essentially looking at the chemistry of the benzene ring in terms of functionalizing it. And your final exam is given on Wednesday, May 11th, and that is a final comprehensive across 255 and 256. Here you see the course grading and assessment schedule. So here is the letter grade, description of the effort involved, the percent of points that you need, and the number of points to achieve that letter grade. Here are your exams, your syllabus quizzes, and the attendance. Again, we're dealing with 800 points that you're out to earn your letter grade. The examination policies, I'll let you read that. Essentially, there are no makeup exams. You can read through this entire policy, which is pretty much the same as last semester. There's tech resource if you need help. The USM academic policies. I encourage you to read the updated health protocol for COVID. Here's the academic integrity statement, including academic honesty, and then USM student support resources, resources for students with disabilities, course workload statement, mental well-being, non-discrimination statement, confidentiality and mandatory reporting, speaking and writing centers, career services, and copyright statement. So I encourage you to print off the syllabus, keep it in the notebook that you're taking notes with, or whatever you have. So the reason that you should have a hard copy is if we circle back to Module 1. So here is a synopsis of the module. Here are the module learning outcomes, which is essentially a study guide for you, wherein the green highlighted verbs are the action verbs from Bloom's taxonomy that you'll need to demonstrate proficiency in the material. But I really want to highlight that in these lecture days for the modules, notice that there's no specific topics given. And what you should do this semester is identify for yourself what those main topics or key concepts are per lecture. Write them in there as a study guide so that you are in touch with the material. So that's a mechanism by which you can organize your notes and your thoughts and study from. So this has been a short tour of the Chemistry 256, Organic Chemistry 2, Spring 2022 syllabus.